This presentation is related to a course on Coursera titled Human Factors in AI. It is a peer graded assignment, the topic of which is we have to choose a project topic on our own and then work through a series of steps and apply our knowledge and skills to design and consider the ethical and privacy implications of a new ML based product. There are two major points over here. We have to primarily focus on design of the user experience of our product, with of course focus on key AI specifications. And the second one being we need to evaluate the privacy and ethical implications of our product, because that is one of the most important thing as well when you are planning to launch an AI ML based product in market. So that is one of the very important things which you need to keep in mind. So I have chosen a project topic related to a combined cycle power plant. So we have a data set over here with over 9,000 records. Uh, we have four input features, which is known as ATV, AP, RH, and there is one target variable. So these input features are temperature, ambient pressure, relative humidity, and exhaust vacuum. Basis these features, will be finding out the net hourly electrical energy output, and this is our target variable. So first of all, we need to do our task analysis. I'll divide that into two parts, which is opportunity evaluation and crisp DM business understanding. So first thing that we need to keep in mind is that we need to provide our users with a front end platform where they can input the features in the input features, basis which they'll get the output result, uh, which is net hourly electrical energy output. At the back end of which, of course, we'll be using the machine learning model, which I'll be depicting over here as well. The problem statement is to predict the hourly electrical energy output. Why ML is a suitable option over here? Because of three options: predictability, availability of data, and business impact. We know that the relationship between environmental factors and energy output can be very complex, and for this purpose, ML models can be a very valuable thing to identify the hidden patterns among the input features and the output variable. We have the ample amount of data over here, approximately 9500 observations, which is kind of sufficient for training and testing of the model. Business impact, will be providing an accurate energy output prediction to our users, which can help operators adjust power generation dynamically. We'll be using crisp DM business understanding in this whole project process. We'll be first defining the success. Uh, the success can be defined by the output metrics, which we'll be using over here. We'll be using mean absolute error, root mean square error, and of course r squared. So, basis these values, we'll be evaluating our model. uh, Over here are use case and stakeholders. So end users will be the people which will be serving our project over. So the business benefit will be the improved power output prediction to our business users over there, who will be kind of working in the power plant. So of course I have done over here an POC over for the model validation. At the end, of course, you can see uh, we have the output evaluation matrices. RMSE is 4.8, MAE is 3.8, MAPE is 0 0.8, and R squared is 0.919, which is kind of uh, very impressive, I guess. Now talking about the user experience design. User experience design, so for that purpose we have to provide a user interaction platform to our users. So we will be providing a web based dashboard or mobile app which our plant operators will be using to input environment variables manually or connect to the live sensor feeds. The system will provide real time predictions of energy output along with the confidence intervals to communicate uncertainty. So this will be the user interaction part. Apart from that, there will also be key AI specific considerations that we'll be keeping in our mind, which is transparency. We'll be explaining model prediction using feature importance visualization to our users over the mobile app or any web-based dashboard. We'll be communicating uncertainty, displaying confidence intervals and reliability scores for each prediction. Also, we'll be using feedback loops at the back end, to keep improving our prediction accuracies. Uh, the privacy and ethical consideration, which I talked earlier about this, it is one of the very important things that we need to keep in mind for the production use cases. The dataset consists of sensor readings, so that is not a PII. So, of course, that will be reducing direct privacy risks. We'll be compliant because we'll be following GDPR. If let's say we'll be deploying this service in Europe, or CCPA if we'll be deploying this in California. Data storage and access will be restricted through role-based authentication. We'll be mm, making the role-based authentication on our mobile app, or let's say web-based portal. So that will be there. Ethical, there will be ethical considerations as well. So as we know, there are bias identification. So possible biases will be there due to seasonal variation or sensor calibration differences. So that is an acceptable thing. Mitigation strategies will be, to ensure data is diverse and representative across different sensors and operational conditions. Also, will be conducting fairness audits to assess any disparities in prediction across different environmental conditions. Also, there will be accountability and transparency. So, we'll be providing clear documentation of models' decision making process with our users to build the trust with them. So, in conclusion, this project has a very strong potential to improve power plant efficiencies through predictive analysis. By leveraging machine learning plant, I think operators can make data driven decisions to optimize energy outputs, reduce waste, and enhance overall operational efficiency while ensuring ethical AI practices and user friendly design.